So number 16 is 18. I'm going to change that to an x, just because I like x's better. Not in real life. Okay, so I want you to compare 16 to 10. So look at 16, and let's look up at 10. I know it started as a log equation, but once we rewrote number 10, it became an exponential. We went from log form to exponential form. So we were solving for a variable that was up in the sky. Our steps were to look for common base on both sides, and we found it with 2. We're starting right at this step with this problem. You need to solve for x. So the first thing you want to do is try to get like bases. But we learned in the last couple of days that sometimes you can't get like bases. 18 and 26 don't have like bases. So we have to have some other method. And what we learned was we can take the log of both sides, okay? Which means give a log to both sides. You are literally allowed to do anything you want to an equation, anything, as long as you do it to both sides. Well, I want to make this side a log, so then I can use the property of log that allows me to bring this x down. So if I want to make this side a log so I can use that property, I just have to be fair and give a log to the other side. You keep your equation balanced. So like I said, now that this is a log right here, I'm allowed to use the properties of logs that say I can bring that log down, that x down on the ground. And remember, I'm just trying to solve for x. Don't let the word log in the problem confuse you. It is a word, but log 18 is actually a number. We learned how to see that in our calculator, okay, before. We'll do it in our last problem here in a minute, too. Last couple problems. But we're just saying this is a number times x. How do I get this x by itself? I would do what? Divide. Divide by log 18. And then we're going to have to put this in our calculator correctly. What are you not going to forget? The parentheses. I'm going to be really obnoxious for a reason. Okay? That's really obnoxious because you really only want it in the numerator. But remember, your log button is right here. So you're going to type in log 26, close your parentheses, divided by log 18. You have to close your numerator's parentheses. And then we'll round to the nearest 10,000th, which is 4 places, just like we've been doing. So that would be 1.1272. I will take off a point if you're rounding incorrectly. Okay. By the way, number 10, you could have used this method when you did this problem. Let me just show you something really quick, guys. Instead of finding a like base, I could have given a log to both sides, which then would have allowed that exponent to come down to the front. Divide both sides by log 2. And if you put this in your calculator correctly, you should get 6. It's the same problem, different method. So log 64, close my parentheses, divided by log 2. And you can see I got 6. Okay, so that log method works for all of the exponential problems. So if you don't like finding like bases, like we did here, you could always use this method. Up to you. Okay. All right, 18 is another exponential function, so it's going to be the same kind of steps. 8 to the negative, again, I'm going to change it to an x. Negative 10x equals 65. Like bases? No. Take the log of both sides? Yes. Give both sides a log. Log 8 to the negative 10x equals log 65. give it to both sides, which allows me now to bring the negative 10x down onto the ground to hang out with the logs. Remember, it's tricky. How do you solve an equation with an x up in the air? We need the x on the ground, not as an exponent. Right? So just like the other ones, we'll divide both sides by log 8. Okay, so I have negative 10x equals whatever I get when I put that in my calculator. So that's going to be log 65, close it, divided by log 8, enter, and I get 2.0075, but I'm only using that really as a placeholder. My answer is right here on my screen. I've got it right here, because I'm not done, right? One last step, what do I do?
Add 10.
Not add, divide, right? This means multiplication, guys, right? Negative 10 and the x means multiplication. The opposite of that would be division. So it's already on my screen. I just hit divided by negative 10. Okay, that's right there. And I get negative 0.2007. Did I get that right? Mm-hmm. Oh, only 4 places, JT. 1, 2, 3, 4. You don't put the 5. That would be 5 places. You see?
I got it.
Okay. All right. And then I'll do one more with you, and that's the other last thing we learned this week, which is the change of base formula. This is calculator work, which is rounding work. Okay? So in number 20, we have log base 3 of 6.2. And it even says use a calculator to approximate this. So how you do this is you rewrite it so you can use your log button. We want to use this button right here, but we can only use this button if we're a common log. A common log means base 10. So the change of base formula makes it really, really simple to do that. We make a fraction with a log on top and a log on bottom, and we put the 6.2 on top and the 3 on the bottom. So the number that's lower, the base, goes to the bottom, base bottom. 3 goes on the bottom. We're not changing any of the numbers. They both get a log, and we're just putting that in our calculator. So log of 6.2, close those parentheses, divided by log 3. And again with the rounding. 1.6608. Right? The 7 tells this 7 to go up to an 8. Right? So I have done at least one of every type of problem that you could encounter, and I've left you 1, 2, 3, 4, 5 problems, 6 problems to do on your own. Okay? So if you're watching this video to review for the test, the